Hello. Today we are going to be learning about some circle conjectures. By the end of the day, you should be able to say, I can use chord and arc properties to discover new information about our circle. All right. The first property we're going to look at says the measure of the intercepted arc is the measure of its central angle. So what this means is if I take a central angle and I say this, what does that look like? 35 degrees, let's say. If this arc in here is 35 degrees, this arc out here is going to be exactly 35 degrees also. Now remember, there's 360 degrees in the circle out here, and there's 360 degrees here, so hopefully that makes sense. The next one says the measure of an inscribed angle in a circle is half the measure of the arc that it intercepts. So here we have 130 degrees, and my inscribed angle is going to be half of that. So if I take 130 divided by 2, I get my inscribed angle. Or if I take my inscribed angle and multiply it by 2, I get the arc. Our next conjecture says, if two chords in a circle are congruent, then their intercepted arcs are congruent. So if we take two chords that are the same, now just to prove that it's the same, I'm going to take this and I am going to copy it and paste it. And I'm going to move that, say, over here. So since these are exactly the same size, the arc out here has to be the same. So if this arc out here was 70, over here would also have to be 70 degrees. Now our last one is parallel lines intercept congruent arcs on a circle. So if I have these two lines and they go through the circle, the arcs that are in between those parallel lines are going to be exactly the same size. Same thing here. If these lines come through, the arcs that are in between them have to be exactly the same size. Alright, so now we're going to do some problems associated with that. If I know my central angle is 127, what is this arc going to be on the outside? Well, if we go back to our first property, the central angle is the same as the arc, so we know that this angle has to be 127 degrees. That degree sign should be a little O in the corner, not a big one like I did. Now if the radius is 8, we want to find the arc length. So we know this is 127 degrees. Now if the radius is 8, remember first thing we have to do is find the circumference, which we multiply 8 times 2 to get 16, and then we multiply that by pi. So now I have my circumference. It's 16 pi centimeters around the entire circle. Now I think it helps a lot of people if they multiply those out. So 16 times 3.14, you'd have 50.24. So the circumference is 50.24 centimeters. Now we don't want the whole distance, we want just this distance here. So we set up the same proportion, 127 over 360 is equal to the arc length, x, over 50.24. Now we cross multiply to get 360x, and 50.24 times 127, and I got 66,380.48. Now when we divide by 360, our arc length is 17.72 centimeters. Now one point that I really want to drive home is the difference between the degree measure and the circumference. The degree measure is 127 degrees, so that's just how much of the circle is being taken up. The actual distance, if I took a tape measure and measured this from point to point, that would be 17.72 centimeters. All right, now let's do this one. Let's find the degree measure of CB. Now first we have to think, is this an inscribed angle or a central angle? Well, since that doesn't go to the center of our circle, hopefully you're saying this is an inscribed angle. So our second property we learned today is that our inscribed angle is half of our arc. So if I want to find the arc length, I have to double that to get 106. Well, that's not the arc length yet. That's just the degree measure of this arc. Now, the next question says, if the radius is 10, so radius is 10, find the arc length of CB. We know that the degree measure is 106. Now we need to find the circumference. If the radius is 10, the circumference is going to be diameter, which is 20, times 3.14. Now if I multiplied 20 times 3.14, I'm going to get 62.8. So 68.2 meters is the distance around the circle. Now to find the arc length, I take my degree measure, which is 106, over 360, and that's going to equal my arc length over 62.8. Now I cross multiply and divide, and I have 360 times x is equal to 106 times 62.8, or 6,656.8. Now I divide each side by 360, and my x value is going to be 18.49. Now I want to reiterate that this is the distance from B to C. That's the arc length, 18.49. The measure of the arc in degrees is 106. All right, now this one says find the degree measure of CB. Now, one thing we can do is multiply, since this is an inscribed angle, we multiply this by 2 to get 208. Now we have a problem, because CB only has 2 letters, and so CB is a minor arc. And if we're looking at this arc here, that's 208, which is more than 180 degrees. So when they say CB, they mean from C all the way around until you get to B. All right, so how do we find that degree measure? Well, you take 360 minus 208, and that's going to leave 152 degrees on this side. Now that's kind of tricky. First you need to use your property to find this angle, and then go back and look at that. All right, now they said that the arc length of CB is 42 pi. So this arc length is 42 pi. We also know it is 152 degrees. Now let's find the radius of the circle. Well, we know 152 over 360 degrees is this portion of the circle, and that equals my arc length over my circumference. We know our arc length is 42 pi. So the first thing I'll do is find my circumference. So 360 times 42 times 3.14 gives me some number, which is 47476.8 is equal to 152 times the circumference. So now I divide that by 152, and my circumference is equal to 312.35. Now, if I have my circumference, that's the distance all the way around the circle. I'm looking for my radius. So my next step is find the diameter. I can find my diameter by taking this number and dividing it by pi, or 3.14. And now I'll get 99 So I got 99.47 for diameter. Now if I take that and divide it in half, so that would be 49.7, that would be my radius. So now, given an arc length, I was able to go all the way and find a radius. All right. This next one, CB, the measure of CB. Now CB is this arc out here. So if we want to find this arc out here, well, we can take these two and go all the way to here, which is an inscribed angle. So since 19 is an inscribed angle, this is double that, which is 38 degrees. All right, now we're at the end of the lesson. Hopefully you can take a second and rate yourself on how comfortable you feel with our goal for today. Our goal was to be able to use the chord and arc properties to discover new information about the circle. Hopefully you're doing pretty well with this. And now you can go to the classwork and the homework.